Greetings, friend, and welcome. Forests are being monitored through sound, not just cameras or satellites. Bioacoustics uses microphones and audio recorders to capture environmental sounds, animal calls, human activity, chainsaws, vehicles, gunshots, and other signals hidden inside the noise of the forest. Now, AI can sort through huge amounts of sound data that humans could never realistically review by hand, helping researchers learn more about wildlife in areas sensitive to human disturbance. Google DeepMind's Perch 2.0 is one such tool, designed to help researchers analyze wildlife sounds across forests, oceans, and noisy natural environments. Humans can only listen occasionally. Machines can listen forever. That changes the forest from something we visit and observe into something that can be monitored continuously. Not by one researcher standing under the trees, but by networks of machines listening day and night. You can already see this shift in places like Costa Rica, where sound is being used to understand animals that are difficult to track by sight. Biologist Jenna Lawson placed 350 audio monitors in trees to study Jeffroy's spider monkeys in Costa Rica's Osa Peninsula. AI systems were then used to analyze the recordings, track monkey calls, and understand movement patterns. Because the monkeys avoid areas near roads and plantations, researchers can now ask whether existing wildlife corridors are actually working. Other researchers in Costa Rica have also been using bioacoustics and ecoacoustics to monitor biodiversity and conservation health. Monica Retamosa at Costa Rica's National University has used remote sound devices in places like the Amistosa Biological Corridor to study ecosystem changes, species presence, and threats through sound. This is also moving on to smaller devices inside the forest itself. A 2025 paper on Malaysia hornbills explored using TinyML to classify hornbill calls in real time on small edge devices. Hornbills are threatened by habitat loss, poaching, and environmental change, which makes traditional population monitoring difficult and labor-intensive. The system uses hornbill audio data, MEL frequency energy features, edge impulse training, and deployment on an Arduino Nano 33 BLE. TinyML means the analysis can happen directly on small, low-power devices instead of sending every recording to the cloud. Forests are not just being recorded. They are starting to be interpreted at the edge inside the environment itself. And sometimes the sound that matters most is not an animal call at all. Rainforest Connection's Forest Guardians began with recycled, solar-powered cell phones placed in trees. These devices listen for sounds like chainsaws and send alerts to rangers, allowing faster response to illegal logging or poaching. Their systems now include custom hardware as well as older phone-based devices. The organization's technology has protected forests in 17 countries across 5 continents, using acoustic monitoring to detect illegal activity and support biodiversity monitoring. Wired reported that the devices can detect chainsaws from over a kilometer away and send alerts within minutes. In Australia, Zoos Victoria used 35 audio recorders across 9 properties to search for the critically endangered plains wanderer. AI analyzed tens of thousands of hours of recordings and helped identify the bird's call in Melbourne's west for the first time in over 30 years, with human experts confirming the discovery. These are no longer isolated experiments. The tools are becoming broader, more flexible, and more general purpose. Google DeepMind's Perch system has reportedly been used by groups including BirdLife Australia and the Australian Acoustic Observatory. Perch 2.0 expands beyond birds into mammals, amphibians, and human-made sounds. The forest is no longer only being observed from outside. It is being continuously translated into data. The rainforest becomes a feed. The bird call becomes a signal. The chainsaw becomes an alert. The ecosystem becomes something searchable, indexable, and eventually predictable. While these listening devices can help with conservation, they can also capture people hiking, camping, working, or moving through the forest without their knowledge or consent, raising serious questions about privacy, movement, and who controls the data gathered from the natural world. The same systems that help protect the forest may also turn the forest into another monitored space, where nature is not the only thing being recorded. Does the positive outweigh the negative? If machines can listen to the forest forever, who decides what they are allowed to hear? Until next time, This has been Micah Sai, and you're listening to the Singularity Hub. Stay tuned for more.